Thanks everyone for coming out. I really, this is an awesome crowd. We don't get this in Boulder very much. So I'm here to talk about PaaS on CoreOS. So first a little bit, let's get my pointer in the right spot. A little bit about myself. I've been doing this for a while, some time in IT ops and systems programming. Worked at some companies, startups, that sort of thing. Early and frequent contributor to Docker, mostly because a lot of the work I was doing was around developer tooling and deployment automation. And created Deis. How many of you are familiar with Deis? All right. So for those of you who aren't, Deis is what I refer to as an application platform, commonly known as a PaaS. Our workflow is Heroku-inspired. The project is 100% open source, and we're mostly, today we're sort of in the move from going from Python to Go with most of our components. So I want to spend a little time talking about why PaaS, because I think, there's a lot of sort of, reasons why you may want to use a PaaS or may not want to use a PaaS. There's, I think, a connotation with PaaS of, especially private PaaS, of big, bloated, enterprisey systems like Cloud Foundries, OpenShifts, that sort of thing. It doesn't have to be that way. PaaS is really designed to solve some specific problems, and I think, for us, the model that Heroku's provided has been, pretty fantastic. So, what does a PaaS really provide that is possibly of interest to some of you folks working with CoreOS? It's really about developer self-service. It's about the idea that a software team can do things on their own that they weren't able to do before. Things like lifecycle management, managing an application through multiple deploys, configuration changes, running of one-off admin commands, troubleshooting, getting stack traces, doing all of this stuff without having to involve an ops team. And that's pretty valuable, but it's not always applicable to every sort of scenario. We recognize that. But it also provides this out-of-the-box solution where the operations team basically sets up the PaaS and then hands the keys to the developers, and you're off to the races at that point. So if you are going to choose a PaaS, why would you choose something like Deis? Well, first of all, we're purpose-built for Docker. And by that, what I mean is the components that the PaaS is constructed with are all Docker images run as Docker containers on CoreOS. And on the other side, we actually deploy Docker containers and are designed to deploy Docker images, which is a little bit different than what you're going to see in a lot of other platforms. I'm going to show you that shortly. Another reason we're powered by CoreOS. We announced this in our 08 release, and the reception when we announced it was pretty amazing. The influx of sort of community folks, and I can tell you it's been one of the best decisions we've made. Not just in terms of the community excitement, but the platform works like order of magnitude better than it did before CoreOS. So, and we're also providing a Heroku-like workflow, and that's pretty important because a lot of folks, especially who are familiar with startups or kind of more progressive developers, are familiar with the concepts and the workflows of Heroku, and trying to jam a new conceptual workflow down a developer's throat, something that they're not familiar with, we've found has been a little tricky. So if you say, well, it's kind of like a private Heroku, people tend to latch onto that, and it makes people more productive, we found. So what do I mean by this developer workflow, right? Well, and if you think about this in the context of Docker, Docker doesn't really allow you to create applications, right? That's not part of what a container is. Really, an application traditionally is a set of multiple containers. At least it is on something like Heroku. Now, you may want to deploy code or Docker images, to your construct of an application. You also want to configure a runtime environment. It was interesting, in the last talk they talked about baking configuration into Docker images. And for the type of workloads like testing and that sort of thing, that makes a ton of sense, and I wouldn't do it any other way. In an environment where you're trying to provide developer self-service, you want the ability to change configuration on the fly, right? You want to swap out a database or swap out a queue or set a debug flag or set some environment variable, essentially, that modifies the currently running application. If you're going to do that live, you also need the ability to manage releases and rollbacks, right? So this concept of an append-only ledger that's tracking the changes to this deployed application is incredibly important. Another thing we've found to be very important is the ability to run one-off admin commands. A lot of the tooling that's out there, manifest-based orchestration tools are sort of all the rage these days, right? One of the things they miss is the ability to run a one-off admin command, like a schema migration or something like that. That's not sort of modeled in that environment, whereas in a platform as a service, you're going to get that ability. Viewing aggregated logs, right? With developer self-service, you're not, the idea is not, oh, go to the ops team and have them go grab you the stack traces for this bug that happened, right? It's the developers want the logs right in their face so they can handle the application themselves, and the ops team can work on more important stuff, right? Not why the developer broke their own app, right? So that's very important, and also the ability to scale out via the process model. We are big believers in sort of the 12-factor style of designing applications, making things stateless, ephemeral, and horizontally scaling. And if you can build your applitions that way, there's a lot of advantages, and the PaaS is really designed to do that. And the last point is really important, collaborating with a team, right? Software is written by teams. It's not written by individuals. And if you're going to provide this type of workflow, it needs to support the concept of users, the concept of who did what when, and access controls and that sort of thing. So with that, I want to show you a little recorded demo here. And how many of you have seen sort of a git push style PaaS workflow demo before? I'm curious. All right, many of you. So I'm not going to show you that. I'm going to show you what I think of as sort of the future of PaaS, which is to say a Docker native PaaS workflow. So what we're going to do here is we're going to do the typical PaaS-y stuff, but rather than git pushing, we're actually going to suck in a Docker image. So to start, we're going to use the Deis CLI, and we're going to list apps. Don't have any yet. And I'm going to create an example Go application. This is actually based on the Google Golang runtime. The Google guys make some really good Docker images if you haven't checked. And this command here, Deis pull, is actually going to fetch from, in this case, Docker Hub. Could easily be Quay. CoreOS Enterprise Registry. Yes, sir. Right? And what it's going to do is it's going to just suck in the layers for that, and it's going to schedule, in this case, one version of that container, and attach it to the router automatically, and you're going to be able to curl it and get it powered by Deis. So you can see that's pretty fast, right? Now we're actually going to get into setting environment variables. In this case, the example app has a powered by, which just is for the hello world here. I'm going to swap that out. And the way that we do this is interesting. We actually model all of the configuration changes as Docker layers that we tack on to a private registry that ships with the PaaS. And so now you can see if we curl this again, the containers are going to be scheduled with this new layer, this config metadata layer on them, and you're going to be able to see that live. I talked about the ability to run one-off admin commands. In this case, just running an env to inspect kind of the process environment, but that could easily be a schema migration. Assuming the app's up and running, we want to scale by process type, right? In Heroku, you typically have web and worker process types. We have a special process type for Docker images called CMD. And CMD is just the default Docker command. So it's just going to run the container without any arguments, essentially. And here you can see that we've now scaled 4, and if we curl it 4 times, and then run Deis logs, you're going to see just the logs for this application, nicely formatted, and you can see we've balanced them across those 4 containers. This is the release ledger that's very similar to how Heroku might model that, and then you can do things like rollbacks, and rollbacks are incredibly powerful and incredibly important. So, our sort of yes, question.
Just a quick question. When
Sure.
you're reconfiguring all the images, is there some kind of downtime, or is that?
No. We schedule the new containers. We wait for them to get announced to the router. There's a short period of time where you're going to run the new version and the old version at the same time. Now, there's some caveats I could talk before, but it is essentially a zero downtime deploy if you're dealing with request response HTTP. So our philosophy is, I want to point out sort of the unique parts in the space. Release early, release often. We release this back when it was really, had a lot of bugs, and there was basically a very simple workflow that worked. But we wanted to get feedback on it, and we wanted to really, our goal was to evolve with the Docker ecosystem. We knew there's all this cool stuff that was happening in the world of Docker, CoreOS, being one of the big things, and we wanted to get something out there and kind of solidify a developer-facing workflow so that we can continue to kind of enhance the way that our components and the back-end implementation worked without actually disrupting developers who have this deployed. Because we have deploys of this currently running with some versions way back, and the workflow, the CLI workflow, hasn't really changed much at all, with the exception of some additional commands. That's something we're pretty proud of. So this has worked out well for us. We have decent traction as far as an open source project goes. We know about 150 plus deployments of Deis in the wild. Deis is being used for things that I never thought it would be used for: financial applications, peer-to-peer, like money transfer stuff, e-commerce, web and mobile kind of dev shops using it for clients. Lots of different ways Deis is being used for production workloads today. Currently, I have 6 full-time developers on the project, about 50 contributors. We are hiring, looking to move that number 6 up. And yeah, so one of the other things I want to mention is our approach. I talked about this before. We've really tried to focus on 12-factor applications because we knew it was something that we could do well. We've invested heavily in automated testing because when you're doing the kind of release early, release often type of stuff, there's a lot of refactoring that's implicit. And if you don't have really, really comprehensive automated end-to-end testing infrastructure, you can't get away with that. And so this is something that we've put a lot of time and resources into. And what I want to talk about today really is that our approach has been to integrate with adjacent projects. And the biggest one here is CoreOS. So I want to talk a little bit about how the CoreOS integration works. So how does it work? Well, the short version is we have about 10 Docker images that do all the PaaS stuff, right? The builder, controller, API server, databases, cache, all the stuff you would expect out of a PaaS. We use Fleet for scheduling. We schedule the PaaS components themselves with Fleet, and we also schedule the containers that developers want to run also with Fleet. We use etcd for coordination, service discovery, shared configuration, and we have a Deis CLI. Ta-da, the end, right? So I can go into a little bit more detail. We have, this is sort of a system diagram here. So the idea is a developer would interact with a controller. And the controller is designed, on the one hand, to sort of curate the set of images inside of a private registry. And this could easily be a CoreOS enterprise registry that's storing this stuff. And on the one hand, so a developer makes a config change or deploys a new build. We actually don't do the scheduling component. That's not part of our area of scope, right? So we have a clean scheduler abstraction that we call out to, and the idea for us is we want to integrate with lots of different schedulers. Fleet is the first one. We're working closely with the folks at Mesosphere. I'm very interested in seeing the Kubernetes talk to see if it's possible to do an integration there, but this is sort of the model. And another view of this is from the standpoint of what happens when you actually deploy a build. So this diagram shows a git push, but the Deis pull deploy I showed is really the same process. In the land of 12-factor applications, you have this concept of a build plus configuration equals a release. And that's really central to what we've modeled here. So whether you're changing configuration or you're pushing in a new build, the net result is a new release. And when that happens, we actually publish that release one way or another to this private Docker registry that we maintain. And then we talk to the scheduler and we say, run n number of these containers of this new release. When those containers come up, we perform some health checks on them, and they sort of announce themselves to etcd, and we publish them to our router component, and that is how they get exposed to the world, right? Pretty simple. This works, it's in production, and we're pretty happy with it. So there's some stuff that we're working on, right? we have some customers who are begging us for the concept of tags. What they really want is the ability to schedule their high CPU jobs onto a specific set of machines, their sort of webby jobs, IO-bound jobs to a different set of machines. And we want to use Fleet's X-condition machine metadata to accomplish this. So the concept is Deis Tags set, work type equals high CPU or whatever it may be. You boot your CoreOS boxes with that metadata, and through our scheduler abstraction, we'll make sure that those containers land on the high CPU boxes, for example. So actually fairly simple to implement. We're going to do some stuff to improve container publishing, streamline log aggregation, Deis CTL utility, which I'm going to hopefully show you here in a minute. But all of this brings up an interesting problem and an interesting challenge in this space. How do we update the platform? If you look around at all the other PaaSes that are out there, no one's really cracked this one yet, right? And part of this is because if the platform is really difficult to install, good chance it's going to be really difficult to upgrade also, right? And having the platform as a series of Docker images, that helps make it possible to upgrade. But there's also other things that we may want to add a Docker image or change the way the topology of how some of the Docker images work. And how we roll those updates out is really, really important to making sure that we can maintain this for customers going forward. Fortunately, we know some smart people who've done some work on this in this space. So how many of you are familiar with Core Update? So Core Update is a service. Yeah, I see the CoreOS team's hands going up here, right? So Core Update is a service that the CoreOS folks have built. It's, in my opinion, incredibly impressive. One of the most underrated things that they've done, in my opinion. It's based on Google's Omaha protocol. And Omaha is essentially client-server protocol that is designed, I think it was originally designed for updating like Windows client applications like Chrome browser and stuff like that. But the CoreOS folks have applied this to server software, and it works amazingly well. It's I believe the similar technology is what they use to roll out updates of CoreOS itself, but it's also possible to use for updating your own software. And we found it perfect for things like host-level updates. It's just it's a host-based model, and it's perfect for that. We also found it can be used to update Fleet units, and that was something that was really exciting to us because Fleet is how we deploy the control plane for Deis. So let's see if the demo gods will allow this demo to go through smoothly. So what I'm going to show you, actually first, what I'm going to show you is the UI. So this is the Core Update web interface, and I'm actually going to dive into an application called the Deis platform. And down at the bottom, I have a CoreOS demo set up. And this is just a small cluster running on EC2, 3 instances. I've enabled automatic updates. And the update behavior is update one host every 1 minute, right? And they have a really cool detail view here. I'm going to dive into the this view. I'm going to change the timeline to an hour so we can get a little bit more granular. And actually, sorry, going back a minute. One of the things that CoreOS has done that you might have noticed is the concept of channels, right? So you got alpha, beta, stable channels. Well, you can do the same thing for your software, and we're planning on doing the same thing for Deis. And so we have some versions, published up there. The one to note is our alpha is currently at 0.10.0. So I'm going to go back in here to the graphs, change this to an hour. And I have here, I'm just checking the journal of a unit called Deis Update on the CoreOS boxes, and I got 3 of them running. And the way that this works is every certain interval, the software's going to, the Deis Update utility is going to check back to the Omaha server, which is essentially that web application, and say, is an update available? And these boxes are all running 0.10, so there is no update available. But we're going to change that, right? We're going to push out a new 0.11. Now this is using Update CTL, which is an open source utility that is essentially used to configure the Omaha server, drive the Omaha server maintained by CoreOS. As you can see, we're calling channel update we give it the GUID of the app, we tell it alpha channel, and we say we want to push 0.11. Now, prior to this, I've actually uploaded an 0.11 package to S3 that includes a tarball, it includes a pre-update and a post-update hook, and really sort of our custom logic for how we want to do these upgrades. So, if I hit enter, let's see if this works. We are going to, hopefully on one of these boxes, there we go. We have something being updated. So this downloaded a package from S3. It is currently inspecting the local units, fleet units that were scheduled to this box, and is updating just those units that were on that host. And we're doing them one at a time. In fact, we actually grabbed a lock from etcd to ensure that we're only updating one host at a time. Now, all this logic was written by us. We're using some of the code from updatectl. We wrote some stuff with the Go Omaha library and some others. We're using fleet code. But the updatectl client actually has the ability to do this. You don't have to write any of that yourself. You can actually just call updatectl. It'll set environment variables for you, and it all works. And one of the really cool things that you'll see is this web UI. You'll get to see we're currently one of the instances. Actually, I got to refresh, I think, to make this look right. I think there's a bug in the Ajax, guys. So you'll see we currently have one node in downloaded state. And we have, right now we have 2 nodes. Let me scroll down a little bit. We have 2 nodes running 0.10. Actually, we have 2 nodes running. Oop, apparently the lock might not be working. Let's take a look here where we're at. Oh, something's wrong with the lock, but we got 2 hosts running. All right, we got this one updated from 0.10 to 0.11. And this actually performed an upgrade of the Deis units from 0.10 to what I've called an 0.11 release. And you can see here in the graph, you have essentially a little visualization of things that are rolling here. So this is incredibly powerful. This is something that you all should be considering using if you're not using it today. And in order for us to solve this problem of how do we update the platform, it's something that we're going to be using. So I'll let that continue to run, and we'll move right along. So what's next for Deis? Stable release. We are laser focused, entire team. All we're doing is spending time focused on getting our stable out the door. And really what that means is platform level HA. In order to make this type of upgrade system work, we need to make sure that we can handle a host failure. So we need to make sure that any state that we have, databases, that sort of thing is going to handle host failures. And we are well in the midst of that work. The platform upgrades is what I talked about. And really leveling up our automated testing. We really want to make sure that we're deploying large-scale clusters, we're doing load simulations on them, we're doing chaos testing, we're pulling nodes in and out of the cluster, and we're not just saying that the release is stable, we're actually proving it through a set of automated tests. Now, post our stable release, we have some interesting plans. I mentioned before, Deis is what we call scheduler agnostic. We're focused on the workflow components. We're interested in leveraging the work of others as to how we schedule containers, and we think that that's a better way, for us to provide value to people. We're, as mentioned, currently working with a team at Mesosphere. We already support Fleet well and will continue to, and interested potentially Kubernetes, and who knows what other schedulers come along. LibSwarm could potentially be an option for us as well. Service gateway. In order to make the service in order to be able to provide the full developer self-service experience, you need to have a set of databases that developers can attach to, a set of queues that the operations team can publish, and that you can inject environment variables from, very similar to the Heroku add-on model. So that's something we're going to be adding, as well as TCP support. We are interested in adding TCP support. We've had some discussions with Sasha and the team working on Vulkan D as a potentially a way to upgrade our router and make it driven by etcd. So interested in doing that. So of course we're an open source project. We love contributors. We've tried to make it pretty easy to contribute to the project. We do require that you include tests for everything. We're kind of sticklers on that. Tests and documentation are sort of mandated. But other than that, we've tried to make it pretty simple. We have a Vagrant setup you can use to develop on this that spins up some CoreOS boxes and makes it pretty easy. We're also hiring. If you're interested in writing Go, you're interested in working with CoreOS and a lot of these other technologies, come talk to me. And I wanted to leave some time for questions. Is there any questions? Yes.
Service gateway piece, are you planning on using Cloud Foundry's service API or?
That's an interesting question. I had a discussion last night with some of those folks about potentially leveraging it. It's unclear as to how much Cloud Foundry-ness is in the service gateway implementation. The other option is for us to kind of use the Heroku add-on model. And you know, the benefit there would be that, you know, Heroku add-ons could in theory work you know, right out of the gate. But we're still exploring our options, and like I said, the team's laser focused on the stable. Yes?
So you've sold me on an alternative to Heroku, but I'm a Heroku developer, and all my stuff, you know, is kind of pack files, and you're telling me now I need to convert that to Docker.
You don't. We support Git push and every build pack that's out there. We are on the latest Cedar stack. You can get, if the app is running on Heroku and works on Heroku, you can move it to Deis with no problem. That's been the case for a long, long time. I thought I'd show something else. That's all. Yes?
How do you guys plan on handling TCP streams related to upgrade?
Could you elaborate?
TCP stream to your running web app, and then I want to push out a new version of the app. So how are you planning on handling that?
Well, that's a really great question. You know, right now the way the platform is architected is to handle really request response type protocols. Part of the reason we don't have TCP support is not because we couldn't find a router that would use TCP. It's all these edge cases around how should you actually do a rolling deploy with TCP services. And I've talked with someone here, Roman, I believe, about, you know, some different ways that you could model that. But it ends up coming down to you're asking the application developer of the software to handle like a term in a certain way, right? So you term the app, and then you have, you know, however long to gracefully shut down the connection and you know, that sort of thing. So, and you know, with Heroku, you have to handle SIG terms as part of the contract as well. So, yes.
So I've read about another project, Flynn, but I don't know that much about it. I was wondering if you could compare the two.
Sure, yeah. So, you know, Flynn is a similar project, you know, very ambitious. They're doing both the scheduling based on Google's Omega, as well as all the platform components, and they have, I think, a third of the people that we do. So, you know, it's ambitious, and you know, we try and work with them where we can, reuse components where we can. We actually help maintain the Slug Builder and Slug Runner projects, which the Flynn folks maintain. But outside of that, yeah, we wish them well. Yes?
What are you guys using for your router?
We're using Nginx right now, and Nginx offers a lot of benefits. WebSocket support right out of the gate, which is important to a lot of our customers. You know, the big downside with Nginx is that you have to send it SIG hups when upstreams change currently, and that's not ideal, and that's why we're interested in something like Vulkan D going forward. Great. Well, I'm going to leave it there. Thank you all so much.